Hi, this is AHC, and I'm going to give you a short introduction to the government virtual machine now. The government virtual machine was written for a capture the flag contest, and it is an interpreter of a custom proprietary bytecode for which no disassemblers and debuggers and whatsoever and no stack protection exists. So if you find, for example, a buffer overflow vulnerability, you can simply exploit it. And if you want to fix it, you have to either fix it in the source code, which we didn't supply to people, only the government bytecode, or you could implement your own stack protection in the virtual machine, right? So, I'm going to show you later how to exploit a buffer overflow vulnerability, but right now let's start with a Hello World program. The programming language that generates or compiles to government bytecode is called ADL. Don't ask me why, it's just ADL. The syntax is inspired a little by Python, but we cannot use the space character for indentation, so we have to tell VI no expand tab. Use tabs for indentation. Also, I have not written yet a syntax highlighting description neither for VI nor for Emacs or anything else, so we'll have to do with plain text mode. The next thing I'm going to do is write a comment. What does the program do? Well, it outputs hello world. Oh, I terribly screwed up. Now, next thing I need is an entry point, which is called main. And I do two things here. First, I say hello world. And second, I say hold. Hold holds the virtual machine. What you can see here is 2 times the same syntax, however with different semantics. First time it is a function call, the second time it is a syscall, namely the hold syscall. The compiler transforms the second function call, or what looks like a function call, into a syscall. Next, I define the function putS. Yeah, that's right, I actually have to write my own function that outputs a string. So, what does this function take as a parameter? It takes as a parameter, well, not a string, but the offset of the string constant hello world relative to the data segment. And it is passed as an integer. Okay, so the main idea is now I know where hello world starts. I'm going to fetch character by character until I reach the null character, right? So I need a variable, character, and here I fetch the first byte, the first character. Peak B gets transformed by the compiler, this time not to a syscall, but to a simple opcode, namely the load byte opcode. I'm going to show this to you in a second in the disassembly listing. So, next thing is we do a while loop, while character, and this means, or this is the same as while character is unequal to the null byte, the null character, right? Python syntax. Okay, next thing is I say put C character, and put C is again translated by the compiler to a syscall, namely the put C syscall. Okay, then I increment S by 1, and I fetch the next character. So that's basically it. That's the whole Hello World program. There are some minor things that I want to do, namely emit a new line character at the end, and I must not forget the exclamation mark. That's it. I can save it now. Okay. So now the next step is to compile it, obviously. The compiler is implemented in Java for historical reasons and for efficiency reasons, because I have to do compilation over and over again, and because Java has a huge loading overhead, the compiler actually listens on a TCP socket. And you can send to that TCP socket source code and it will send you back bytecode. This is lucky for me because, well, I don't have Java installed, but I can use the C wrapper. So it takes as a first parameter hval.adl and a second parameter hval.govm, which is the output file name, and then the IP of the host name, IP of the host where the compiler is running, which is in my case this one. Connection refused. Oh damn. I have, of course, first to start. Hold a second. Right, I first have to start the compiler. My connection to this remote host has timed out. And now it should be running. Great. Okay, compilation successful. And I have successfully now generated the file hvalt.govm. If we have a look at it, here we see the string constant hello world, right? Terminated by the null byte. Okay, so why do we have to call the compiler so often? Well, in this example we don't, but during the CTF contest, the same source code was compiled over and over again. The reason for that is that the compiler at random positions injects NOP syscalls, opcodes here, and the reason for that is people are not supposed to be able to tell what the script does, the bytecode does, once they have run it by calculating the hash value, right? Now in this case, if I compile it again, it will behave the same way, but it will have a different hash, right? It has now, again, a different hash, and if I'll have a look at it, does it look different? I can't tell, but I can tell that hello world is still here. So the important parts are still there. Okay, so next thing is, obviously, we want to run it, right? For that, there is a Python module which is called govm.so. It is actually implemented in C and exports the function run to Python. So, in theory, I just do import govm and say govm.run, but govm.run takes some parameters, and for that I have to just write some small Python code, which I'm going to call run hw.py run hello world, right? So the first thing I do is obviously import govm, and then I have to fetch the bytecode. Bytecode equals open hvalt.govm, which is the file I just compiled, and well, actually it's a result of the compilation, right? And rb means open the file read only and in binary mode, and I say .read, now bytecode contains the bytecode, and I say govm.run bytecode. However, I have to supply some more parameters. Second parameter to the run call of govm is a string whose bytes will get appended to the initialized part of the data segment of the virtual machine. I do not need that feature right now, so I supply the empty string. The next parameter is sort of reserved or deprecated. I'm just not going to tell you what it is. It's not important. We don't need it. The fourth parameter is the putc syscall. I have to implement it in Python, which is the sole reason why this virtual machine has actually been implemented as a Python module. And getC I also have to supply. So, now I have to write a function for putc, and it gets passed a character. And well, I want to output that character. I say sys.stdout.write character, and I say sys.stdout.flush, because I have to flush it, right? So the character gets actually displayed, because stdout is line buffered, and I'm not going to look into how to make it character buffered, which can be done, but well, flush does the job for this simple proof of concept. So next thing we need is getC, and I just say sys.stdin.read, and I realize that Python is not functional, not completely functional at least, so I have to explicitly return the value. Okay, that's it. Now if I did everything correctly, I should see hello world. There we go.